Hello everybody, how are we doing? So really quick, those of you who are doing lesson 2.2 notes, here is a quick screenshot or a quick picture of what lesson 2.1 should have looked like by the time they finished. Whether they looked online and just copied this chart down and did all the work, but this is what the work was supposed to look like. Please remember that the payment depends on the kilowatts used. They should have input and output, understanding that these are the X's and these are the Y's. And we went through and we found what we call the first differences for all of these. We know that when we put them as a fraction, they become a rate of change. Okay, so after we do that, you could have answered the questions on the back. The rate of change is where you take this and reduce it. So this would be 1400 over 1,000. It reduces to 14 over 10 over 100, which is 7/50ths. And if you did 28 over 200, you also get 7/50ths. You divide both by 4. Some of you might be asking how we got those numbers. Those were our first differences: the 140 over 1,000 and the 28 over the 200, and then 28 over 200, and then 28 over 200. So that's how we got those fractions. It's our y's over the x's. Our y's over the x's. Just like when you have a graph, you have the y's over the x's. Okay? All right. So that's what you should have done. We talk about rate of change, that this is called a rate of change. Looks like it's 7 cents for 50 kilowatts. We reduce it. And then, of course, this is called the unit rate when we're charging per kilowatt. So when we do the division of 7 divided by 50, we get 0.14, and this is now called a unit rate because the denominator is 1. And then, of course, just being able to label the graph and then graph the points. You have the points from the table, so you take the table points, you put them on the graph. Some of you are starting to realize, holy cow, this is a lot like the software. And you're right. That's what we're doing. And some of you should have noticed, hey, wait, this is like the skill practice. Yes. These are all extensions of the same topic. All right. So let's look at another problem in 2.2. Now, as you can tell by the title, it says, what goes up must come down. So hopefully you've pulled this offline and you understand what we're going to talk about. I'm actually going to use this sheet this time to kind of go through things you should notice. So, for example, we read this. Lynn and her friend Thomas are collecting food for the local food bank. Their goal is to collect a total of 1,785 pounds of food. They start with 225 pounds donated by the local grocery. Their goal to collect 20 pounds of food per day. There it is, per. Circle it. This is my correct dependent. This is my independent. Okay? The problem is, most of the time, these are my units. Okay? And I don't need the units. I need the quantities. So this is food, right? Is that our dependent that goes there? No, you should have said, wait, Mr. Frazier, you're making a mistake. Stop. Okay? Correct. You should have here as your independent. The second thing is independent, which is time. Remember, we can't control time, so time is in your independent. Time is measured in this problem in days. So that means all these numbers here represent days. Okay? That's what they represent. They are our X values. They're also known as our inputs. So all these vocab words you got to know. Okay? Then over here are our correct outputs. And what is our output? This would be food donated. And that one's measured in pounds. So we got pounds. LBS. Pounds. Okay? So understanding that's how we get our quantities. We've been doing this since chapter 1. So it's the amount of food per day And the important part is that the day is your independent, so that's the unit, and that's a unit of time. And food is your quantity, and it's measured in pounds. Now, the nice part is it says 20 pounds per day, which means this is our X, right? Per day, per X, 20 per X. So how would I write that? 20 per X, or 20X. But, is that all it said? Anybody? Is that all it said? Was 20X? Now, if we're down here, we know this is our X value, so I'm going to change this to X. Why is it that we don't want to use T? We don't want to use T a whole lot. Why? Because it looks like a plus sign. Okay. The problem is we started with how much? 225 pounds of food. So, is this starting with 225 pounds of food? No, it's not. So what do I have to add to this? Correct. I have to add 225 pounds of food because I'm starting with this much already, and then I'm going to add to it. Okay. So my expression down here is 20x plus 225 pounds. So here I have my expression, and here I have my expression. These expressions, this is the only one that is an actual expression that has numbers in it. This one has a tendency of always being the what? Correct, X, because we only have one input. All right, so now I look at the table and I'm like, okay, now I got to complete the table. This is just like the software. Except when I put in 0 in this part of the table, in the independent, it automatically, wham, gave me the answer. Well, now I got to actually do the math. So that means these are all my X values, my inputs. So I put it in. I'm inputting the value. I input it. So the first one would be 20 times 0 plus 225. Second problem is 20 times 10 plus 225. Third one is 20 times 15 plus 225. I am doing the input. The next one is 20 times 25 plus 225. Now notice, these are all inputted, and I'm going to get an output value. That output value is also known as my Y. It's also known as my f of x. Whatever my expression is, I plug in the input and I get the output. Well, what's wrong here? Here they're giving me the output. I need what I put in. So hopefully you know everything is backwards. So I'm going to write what this is, except I'm not going to have the input. I just know what it equals. So I can write the same problem. The only difference is now I have to work backwards. It's still the same math problem. I just have to work backwards because now I'm trying to find this. So as you notice, I just put all the same work over here. The only difference is, in this problem it's equal to something, and here I'm putting in the answer because I have an input, so I get the output. Here I do not have the input, and I need the output. All right, so you should be able to fill out the rest of this table. This is simple math. And in here, what would you do first? You'd subtract 225 from both sides. Then you'd have to divide by 20. Here you'd subtract 225 from both sides, and then you'd divide by 20, and you'll get what your x is. All right? Now, here it says write a function of the problem. Well, I know that if I write an equation would look like this. Y equals 20x plus 225. That is an equation. Why is it an equation? It has an x and a y and an equal sign. But a function has to have what? F of x equals 20x plus 225. Now they talk about f of t. Well, the problem you have to make sure is that if you use that t in the problem, you have to use t. So that, and we try to avoid that. I'm okay with you using f of x all the time because the t has a tendency of looking just like your plus sign. And some of you will go, well, what is 20t 20 plus plus 225? No, okay, so we try to avoid that. But this would be the function because it's written in function notation. This looks just like it, except of the y. That makes it an equation. So this is an equation, and this is a function. It's how you write it. The numbers aren't a whole lot of different. It's the fact that you use the function of x, function notation, from chapter 2:1. Now, they want us to be able to identify the y-intercept and the slope. So where did I start? Well, we have to make common sense of this. It's no different than when we talk about certain things. If we started with the airplane, remember the airplane started on the ground. At 0 time, it went 0 height. And then as it increased, it went up. Well, the problem here is we're not starting at 0. How much did they already give us? We already had 225, which means we're starting somewhere around here. Now we have to kind of estimate because we don't have exact numbers. Okay? Graphs, as you're seeing, are very inaccurate. Graphs are inaccurate. They present the information as a picture, but they're very inaccurate. This, getting the numbers, is very accurate. Hopefully you understand you should have the rest of this chart filled out. I should see your math work, especially for these two problems when you have to do the algebra to solve. This is just calculator work. Getting the answers easy. This you're going to have to solve. I want to see it. Now in the computer software you can use the solver and you're transforming this problem and it tells you subtract from both sides and you put in the number 225 and then divide both sides by 20. So the solver work becomes relatively easy. Alright, so now we have to identify the y-intercept. Well, let's look at this. If we started at 225, that means the y-intercept is where? It's where my graph is going to touch the y-axis. Well, I started at 225, so that means that y-intercept is 225. But it's got to be listed as a point. So the y-intercept is 0, 225, meaning I don't go left and right, I just went up to 225. Because we started with 225. So in the problem, what you start with is your y-intercept. And your y-intercept is the amount that you start with. Alright, last but not least, interpret their meanings in the terms of the problem. Well, this y-intercept tells me that I started with 225 pounds of dog food. Okay? And the slope is the number that's where? Hopefully you understand I'm collecting 20 pounds of dog food per day. So, I'm collecting 20 pounds of dog food per day. How much I'm doing per is my slope. It's also my rate of change. $20 per day. Hey, wait a minute. If it's $20 per day, that means the denominator is 1. That means 20 over 1 is also known as my unit rate because the denominator is 1. And hopefully you understand that 20, when written as a fraction, always has a denominator of 1. So now they want us to look at this, and after I graph a couple of points, okay, so I'm going to do 0, 225, and I'm going to do the next point. 0, 425. So I'm going to graph the next point. It started here, or it's 10, so I do 10 days. Now, here's the key. Are these in intervals of 20? Some of you are going to say yes, and you'd be wrong, because intervals are how much each line is. So hopefully you see it goes blank, 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 20. So they're counting by 5, 10, 15, 20. Their lines are by 5s, but they put down 20 spaces. So they think, making you think, oh, I'm counting by 20s. And you're not. You're counting by 5s. So that means 5, and this would be 10. And at 10, we said we had 425. So at 10, I do 425. Now notice, I am estimating. Why? Because I don't have 425. I just know 425 is a little bit bigger than 4. These are going by intervals of what? Correct. Hopefully you said 100. Because if they're not by 200s, it's just they didn't put every 100. So there's 100, 200, 300, 400, 500, 600. So again, you just put it a little bit above 400, and now we have 2 points. Once we have 2 points, we can draw our line. The software makes you have 3 points. The software makes you have 3 points. I'm telling you we're only working with 2 because you have to do it longhand. Okay, now it says, estimate the numbers of days it would take to have 600 pounds. So here's my 600 pounds. And I go trucking across. I need 600 pounds. I go to here, I get to here, and then I go down. What do you get? Hopefully you know you're going to have approximately 20 days for 600 pounds. Now you could have said approximately 18 days. You could have said 19 days. There really was no wrong answer except saying 40 days. That wouldn't make any sense because 40 days is way up here. Remember, we're going 600. So that means in our mind, we're going across and seeing where I touch. And here, it seems to be touching at 20 days. And if you look at your answers, you should notice on your table, you're going to see that the answer is in between 15 and 25 days. All right. Hopefully you understand what we're trying to do and understanding that we use a graph to do estimations, but if we want to be really accurate, we use algebra to be accurate. The table could tell us exactly. If we wanted to know the exact amount of days for 600 pounds, we would just put 600 pounds and figure out the amount of days. And it would tell us accurately. The problem is, when we do that, so let's do it. Let's put 600 pounds. So we'd have 20x plus 225 equals 600. Now we do our math. We minus 225, and you get I'm waiting. Correct. 375 equals 20x. What do I do next? Hopefully you said divide by 20. Correct. And you should get 18.75. So, how many days will it take for them to collect 600 pounds of food? Hopefully you did not say 18.75. How many days will it take for them to collect 600 pounds of food? Hopefully you said 19 days. Because they're trying to be what? Discrete. They're trying to be discrete. They're saying, how many days will it take? Not part of days, how many days? 18.75 days? Well, we can't have pieces because they want an exact number. Well, they're estimating, but they want a number of days. They don't want part days. How many days would it take? Well, it can't be 18 days. Because if I do 18 days, I'll have less than 600. So it's got to be more than 18 days. Okay? So the only number more than 18 days is 19. Okay? So in order for us to get to 600 pounds of food, it would take us 18.75 days, but we don't count days in pieces, okay? Because they're wanting a discrete number. So they want 19 days. Hopefully you understand that. It's kind of like saying how many chaperones do we need to go if we have every 10 children gets one chaperone, right? So I'll do this as an example. Every 10 children gets one chaperone. If there's 12 children, how many chaperones do you need? Well, you can't have one because you have to have at least one for every 10. So how many chaperones would I need? I'd need 2. You can't have 1.5 chaperones. Okay, so if I have 12 kids, I've got to have at least 2 chaperones until I get to the number of kids of 21. Once I have 21 kids, now I need a 3rd chaperone. So there is no rounding in this, but you have to make sure that you understand that you can't have pieces. When they estimate the number of days, you need to say the days. Okay, you can't give me pieces of days. And of course, if they're saying estimate, they really don't want you to do the math. I'm kind of showing you what's coming down the road, understanding what is happening. And we know that this is the rate of change because it's 20 per day. Wherever the per is my rate of change. All right. Well, that's it for 2-2. I hope you understand what we're talking about, and we can move relatively quickly through 2-2. You should start seeing a lot of similarities between what we're doing and the software. You're still going to have to be able to label this graph. I didn't label it, but you need to make sure that you have the ability to label it. So what would go here? Hopefully you know this would be pounds of dog food, or this would be dog food. And it's measured in pounds. And this would be what? Correct? Days, or time, time measured in days. All right, so you still have to have those things done. I didn't necessarily do them all because you're expected to fill them out. Okay, so hopefully you went back and finished the problem. Those of you who don't have these printed out, hopefully you froze the video and wrote out what the answers mean and what they're for. And I will put up 2-3 on Friday, and you will have that for Monday, 2-3 and 2-4. We should get through 3, 4, and 5 next week, I'm hoping. All right, have a wonderful day. We'll see you.